Hi, my name is Ruben. I'm a software engineer on the MySQL Optimizer team. So I'm here to talk about MySQL and Gis. It's going to be a quick introduction to Gis and MySQL, crash course for those that use MySQL and don't use Gis and want to do that, or for those of you that understand Gis, this is an introduction to what MySQL can do. So how many of you guys are using MySQL? How many of you are using MySQL for Gis? Was one hand? Yeah, great. Cool. So I'm going to go through the first a few slides about MySQL, what we're doing, how we're, what's going on in MySQL at the moment. Then some Gis basics, really basic stuff. For instance, what is a point? I'm going to show a small example of SQL, how to use this, and a short thing about future directions for Gis and MySQL, and then we'll do a Q&A afterwards. So let's just jump straight into it. MySQL is what we like to call the world's most popular open source database. It's very popular in web backends. So if you, almost every website these days have a map. So using MySQL for Gis in web maps is kind of the obvious choice in that direction. We've had Gis support for many years. It's not the most advanced Gis support we've had, but we've had something. But with 5.7, we released MySQL 5.7 in October last year, and in that time frame we really started working on Gis. We staffed up a Gis team, which I'm part of. The main thing we did in the server, MySQL server, was to actually replace the entire Gis engine. We had some homegrown algorithms. We decided to swap it out with Boost geometry. If you're using, does anyone know Boost, the C++ library? Yeah. They have a geometry library there. They have more or less the same goals for OGC compliance, everything that we have in MySQL. So it was a very good match. The big feature of MySQL 5.7 Gis is that you have spatial indexes in InnoDB. So if you know MySQL, you have MyISOM, which is the non-transactional old storage engine, and InnoDB, which is the modern one with transactional support. And until 5.7, you could only get spatial indexes in MyISOM, which was a major drawback. So our implementation is based on Boost geometry. We swapped out what we have with Boost geometry, which removed a number of bugs. We introduced a few more, so we fixed those. And it wasn't complete, so we extended Boost geometry to support what we needed to replace our functionality. And we contributed all this back to Boost geometry. We don't want to maintain a Gis library, we want to be the users of a Gis library. But we had 2 guys working full-time on extending Boost for the last 2 years. And in the foreseeable future as well, we will continue with that. Unlike some other open source database management systems, this is built in. It's not like PostGIS where you have an extension. This is a first-class citizen of MySQL. This is kind of one of the main selling points. This is ready to begin with, out of the box. Then on to the basics. Gis in databases is not really hard, I can say, at some level, at least when you have a library that does a little map for you. So what you need is basically data types. You need an index so you can make optimizations and search fast, and you need functions to calculate things. And as long as we're using Boost, those functions are almost free, unless you count the people that are actually implementing those. For me, I'm not working on implementing actual math. I'm implementing this in MySQL, so I just see the interface of the Boost. So for me, Gis in MySQL is just a database with a couple of R trees stuck in it, and some data types. So we support the simple data types from OGC simple features basic ones. These are 8 types. It's a hierarchy. So you have a geometry type. It's not instantiable, but it's nice as a column type that you can store all the other subtypes in it. So the 3 basic types are points, line strings, and polygons. I'm going to go through very quickly through all these in the next slides. And we have collection types, generic collection and collections that are type specific. And all our functions support all these types. Unlike some other open source GS databases, we also support geometry collections in all functions. Yeah, so you have data types, points and lines and stuff, but they need to be in a spatial reference system. Like if one point is at coordinate 0.0 on Earth and one is at 0.0 on Mars, they do not overlap. So you need to know which reference system you are in. We currently support only 2-dimensional Cartesian flat systems, so kind of an infinite plane. That is a shortcoming, but for many use cases it's good enough. And the major drawback with what we have today is we don't have a catalog of these systems. So we don't know which ones are flat and which ones are spherical or ellipsoidal. So currently, if you want to do JS in MySQL and want to be on the safe side, maybe kind of SRAD 0, which we have, which is the infinite unitless Cartesian plane, is the safe choice. But you could also make a pretty safe bet that when we get this catalog, we will follow the European Petroleum Survey Group's codes. So 4326 will be kind of the GPS coordinate system, and this 22500 is kind of some North American projection or something. So you can use those codes and can be pretty sure that you will get what you expect. But for the moment, all calculations are done using this flat space. So if you use something that is ellipsoidal, then at some point it will change how it calculates this. Points. Point is, in our space, a 2-dimensional thing. These are all ways you can generate that point. You have one function with the same name as a data type that takes the coordinates. You have the well-known text format from OGC, GeoJSON, GeoHash. The longer that string is, the more accurate that point is. Well-known binary formats. And I think most of these take a parameter where you can specify which coordinate system this is. You don't have to specify it. If you don't, it's default 0. Line strings are a connected set of line segments. Just specify the points, and it's all connected. It's obvious what is on a plane. It's the shortest path. When you go on a globe, it's going to be a great circle, and kind of with different systems, this will change. Polygons. Polygons are all polygons. They have one exterior ring. They might have 0 or more holes, that's interior rings. There are at least 4 points. You have to specify the starting point is the same as end point. So the triangle there has 4 points. Just to close it off. And you can specify this in a clockwise or counterclockwise direction. MySQL will flip it for you. Internally, we're using counterclockwise for outer ring and clockwise for inner rings. So you might get a slight performance benefit if you do that as well, but it really shouldn't matter very much. We will auto flip it as needed. Multipoint is a collection of points. Multiple line string is a collection of line strings. It's kind of nice. Multi-polygon is a collection of polygons, but they really shouldn't overlap. They can overlap. We'll store that. We won't have a problem with that, but you can't really calculate a lot of stuff if they do. We have a function called, let's have a try, I'll talk about that later, but we have a function to check if it's geometrically valid. It limits what you can do if it's not. So, geometry collection is collection can contain anything. It can also be empty. This is the only type we allow to be empty. I know the ODG standards specify that any of these types could be empty, contain nothing. Currently, we only allow the geometry collection to be empty. So if you have a polygon over here, a polygon here, and compute the intersection, there's no intersection, so you get an empty geometry collection as a result. So the summary, these types contain the geometry and the spatial reference system ID. That is what we store binary in MySQL. All coordinates are double precision coordinates. We can store invalid geometries. If you're unsure if your data is valid or not, you can check it. We have a function to do that. This is all kind of in the normal SQL multimedia standard and in the Open Geospatial standards. Yeah. Then we have functions. They're only defined for the valid geometries. If you try to compute something on invalid geometries, if we detect that, we will give you an error message. If you don't, you might get kind of best effort results, or since our algorithms are assuming that these are valid, you might get a very weird result. That's the typical way of handling this as well, because you can't really guarantee anything in these invalid geometries. So you need to make sure your geometries are valid if you're going to use them for computing intersections and unions and stuff. Or maybe, well, actually, union might actually be one of them where you make an effort and try to really make a union, because overlapping things are kind of what union handles. And you're not allowed to mix different coordinate systems. We'll just bark at you and say no if you try to compute something with two parameters in different coordinate systems. We have currently no way of transforming between these coordinate systems, so you will have to stick to one. We have a lot of functions, so we can compare things. Is one point within on a polygon, or what is the intersection between two polygons? What's the area of a polygon? What's the length of a line? What's the x coordinate or y coordinate? Or how many objects are in a collection? That kind of thing. We also have analysis functions like centroid or convex hull. And we have import and export functions. There's a lot of import functions. They use the same format, which is specified by the standards we have to be there. There are four formats: well-known text, well-known binary, GeoJSON, and GeoHash. That's what we currently support. And we optimize using our trees. You don't have to do anything in particular. We will recognize functions. You see, top ones here are the standard functions. You have some simpler functions below that will use only the bounding box. So two polygons that kind of are very close and have weird shapes, they might not actually overlap, but the bounding boxes will overlap. And we have functions for that as well. Because if you don't need the exact shape, those are so much faster to calculate. So you do performance improvement if you know you don't need it and you just use those functions. Now my example. This is a very simple example, but if you want to know how the SQL works, this will give you a very brief introduction to that. So we're going to go sightseeing in my hometown of Trondheim. I'm going to make a simple table with 3 columns. There's a unique ID, just because I like an ID for every point I have, position, and a description of a site. So the description will probably just be the name of it. I'm creating a table called sites. My ID is an integer, it's auto-incremented, it's a primary key, which means this table is going to be indexed by that key. I have position, which is the type of point, which means if I have a park, I would pick one point for that park, not a whole polygon. It wanted to have both points and polygons, so I would have to pick the geometry type for that column. The description is just a string, and I have a spatial key, which is a spatial index we write as well, synonyms as well. I call it my R3, and it's an index over the position column. If you see that position column has point not null, if you're going to index it, it has to be not null in MySQL. We can't add null values to these R3s. This is one limitation of the implementation. So let's insert something into it. Position is 10 degrees east, 63 degrees north, and that's the cathedral. That's a church in the city center of Trondheim. We can select that point back again as well on text. We'll get a textual representation of the point and the name of the place. It's really, really simple. So let's add a few more points. This shows you some additional formats. So one thing on Trondheim, if you've ever been there, there are other tourists that are mistaking the main building of the university for the Nidaros Cathedral. So we add that to the table as well, so that you can figure out what it's for. We do that with GeoJSON. You see the format of GeoJSON up there. It's just a fragment of GeoJSON. It's not the entire document. But you could also add the entire document in there. And we have the Civil Society building, which is an architectural monument on Trondheim. It's also outside the city center together with the university. Here is an example of adding the SRID to the thing. Kind of the other ones, when we don't specify it, it will be 0, except for GeoJSON, where the standard specifies it should be 4326. We also add the monument over the Viking king that founded the city, which is that in city center. It's just added as well on text again. So our sites are here: University, the Student Society, the Cathedral, and the statue at the top. And in Trondheim, we usually define the city center as this area. It's a polygon. By the way, this is made using a tool called Wickets. It's a nice tool for just plotting well-known text, an online tool. So that is the city center. As you see, 2 of these sites will be inside, 2 will be outside of the city center. So let's try to get the database to answer that question. Find all the sites in the city center. First, we define that polygon that we saw. Just plot it into a user-defined variable in SQL. Then I select the name of all the sites where the position is inside the city. So this would, well, depending on the size of the table and everything, but it could use the R3 at least to look this up. If the optimizer thinks that would be the best thing, this table is very short, so it might just scan the whole thing. So what do you think the result is?
Error.
An error, yeah, because I mixed SRIDs. So I have to fix that first. Fix the SRD. We don't have a function to change the SRD of an object. That's a real simple thing to implement, so we probably should. But for now, we just export it to a format that doesn't support the SRD, and then import it back in again with defaults. It's not very efficient, but it works. Then we can do the query, and we see that MySQL gives you the correct result. That is really the ease of geometry in SQL. Just type the expression and you get it. It's not rocket science in any way. Kind of rocket science is on the inside of the mathematical equations. So that's what we can do today. So this is only a simple example, but still, we have much more to do in the future. We just started on improving JS like 2 years ago. So someone told us that Earth isn't flat. I'm inclined to believe that. So ellipsoid Earth model would be nice. Boost Geometry is already working on extending that. There was a talk at this one of these big C++ conferences last year about how they were doing that in Boost. I think it was Clive Marshall actually holding that talk. And we can add projections, define the projections, and transformations between all this. Boost is using, I think they imported Proj 4 into Boost and templatized it. They claim it's faster than Proj 4. I don't know, but that's the claim at least from those guys. We'll add some metadata tables that the standards are compliant I'm saying we should have. Really try to be standard compliant on this. I think maybe we might end up being more standard for compliance than positives for what we do. 3D and 4D support. Adding data types is quite easy. It's the functions that will take time. So just adding data types might happen. If you add 3D, you might add 4D as well. But otherwise, if you have requests, we will be happy to take them. Because it's much better to have you guys saying what we should do instead of me telling you what you can do. Let's have a talk if you have your some spatial needs. We can discuss that. I think I'll just end with a few words from the Dominator. This is MySQL Gis is kind of like Google Maps but better. I think we have time for a few questions. Yeah.
So if you say non-flat Earth, does that include stuff like being able to query which points are less than 5 kilometers from this point?
Yeah. So the question is
right now with not knowing projections, that probably doesn't work. Right?
Yeah. So the question is about the non-flat Earth. Will that include things like calculating which points are within a 5 kilometer distance from this place? Actually, with the flat model, you can also do 5 kilometers. It's not that far. You will get a pretty accurate one. But yes, if you take a point and take the buffer of that, extend that to a 5 kilometer radius, and try plotting that. Well, yeah, try plotting that on the map. You will see kind of an ellipsis. If we add full ellipsoid support, that would not happen. You get actually 5 kilometer radius. So yes, that would be also on the ellipsoid. That was Christopher first. Yeah, I think you were first.
Fine. So yeah, I do some volunteer work at an archaeology department basically. We do a lot of tutorial stuff and that gets very complex. And we are really interested in 3D GIS because of course we have like tubes with skeletons in them and that data is very important to us, not to talk about like the different layers. How close is the implement, how close do you think the full 3D support and 4D support would be? Are we talking 3 years, 5 years, 10 years?
Okay, so the question is about how close is 3D and 4D support, because they want to model dead bodies in crypts or whatever. Yeah,
Among other things, yes.
Well, just modeling them, just storing the points, that is an easy thing. So, do you need more than that? Do you need operations on those?
We will mostly be working with areas and then points in them. So where certain finds were found in certain areas, either ground layers or, for example, tubes or stacked tubes, for example.
Okay, so you're working in one area, but do you need to kind of find the things that are in a volume, or is it just in a 2D area?
Could be either.
Okay, either. So, for instance, to find things in a 2D area, the way the standards are kind of defined now, all these functions somewhere. Here, for instance, is that if you give a 3D point into any of these functions, according to the standard, it should do a 2D operation for you. So there are separate functions we have to implement to get the full kind of find things in a volume. So that's a slightly different thing. But 3D, well, it depends. we have usually like 2.5 years between each one of these Mysql. For 5.8, I'm not sure I would expect more than kind of geography that sort of support, but so maybe take a couple more years for the next major release. And it all depends on priorities. But as we say, 3D is people are wanting 3D, so at least the storage part should be quite easy. The math is well, maybe we could support some math, but not all of it. Do you have time for this last question?
Yeah, go ahead.
Yeah, sure.
You know the reason why you incorporated the SRIDs to the columns, to the rows, not to the columns?
Okay. The question was when you incorporate
Because you can
rows
implement
of
SRIDs. And that's a bad thing.
So you asking if why we allow different SRDs in the same column? Yeah. Well, actually, I wasn't around when that decision was made many years ago. But what we are looking at is to say that we can restrict that column to an SRD. We haven't implemented that yet, but that is definitely something on our map because this will screw up indexes and everything. We don't have it. So that's definitely something we are interested in. Thanks for listening.